Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their business. In fact, the BP committee just released a beta version of the latest manual, which is 6.1. CSIA also offers a certification program and other resources, including professional development, learning from peers, access to vetted professional services companies, including insurance and legal, who understand an SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are currently not a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events like this one, as well as other resources from accounting to sales to operations, 365 days a year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you are currently a member, thank you. If you just want to get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature here in Zoom. That's going to be in your navigation ribbon. That helps us stay organized. You're also welcome to chat amongst yourselves using the chat feature, and inevitably somebody's going to put a question in the chat, and that's okay. But if you can try and use that Q&A feature, it does help us a lot. The session is being recorded, and you will get a link to the recording in the next day or so. And now at this time, I'm going to turn it over to today's speakers. Take it away, guys.
Thank you, Lisa. And Doshik, if you'll get our slides.
Okay, can you confirm that you can see that?
Sure can.
Okay, well, thanks for everyone joining this morning. We've got a lot of ground that we're hoping to cover and have a good discussion here. So we'll start off with some quick introductions, just our initial disclaimer here. It's part of the deck. And I'll hand it over to Rudy for a quick intro.
Hi, so thank you for having us. My name is Rudy DeAnda. I handle strategic alliances here at Stratus Technologies. My background, I started in industrial automation with the Rockwell automation ecosystem, really addressing a lot of the industries that Rockwell plays in, and then I moved over into process automation with Emerson. I've been in close proximity to deployment of a lot of projects and cutovers, both in the process world and the discrete world, and we're excited to share with you some of the findings of what we think can help improve your profitability in this space.
Thanks, Rudy. And for myself, I lead product marketing and solution marketing over at Stratus. I've been focused on industrial software and automation for the past 15 years, and the areas that I really focus on are use cases and getting a deep understanding of where people are being successful and where they're achieving, what people call, digital transformation, but, tangible examples of that. In our discussion today, it's 5 edge opportunities to maximize revenue in 2024. So we're going to cover a lot of ground. You can see the quick agenda here on the right-hand side, and we'll go into that obviously in a lot more detail. But to start out, many of you on the line know Stratus. For those who may be a little bit less familiar, a quick overview of our focus. In simple terms, we build the most reliable compute platforms on the planet. They're purpose-built to run mission-critical applications without downtime or data loss. And we've been doing this for more than 40 years. In fact, our most recent platform, ZTC Endurance, it's built on more than 100 million hours of runtime analysis across thousands of customers. And when you think about reliability and compute and data processing, that really goes hand in hand with modern industrial control. And so we have this philosophy of simple, protected, autonomous. That's what we build into all of our platforms because we're focused on industrial automation. And you'll see that throughout the discussion here. But just to top line it, simple, the platform's got to be easy to install, easy to maintain, easy to scale. Without a lot of technical knowledge, it's got to be manageable by OT and IT today. Protected. So it can't go down. It's got to be available. It's got to deliver the maximum amount of reliability. You can't have any data loss, and oftentimes it's got to be ruggedized for that edge environment, and it's got to be protected from a cybersecurity standpoint from external threats. And autonomous, something that we build in that's unique to Stratus. We have automated processes. We have proactive health monitoring and alerting that's built into the platform. So again, you don't have to be an IT expert or a server expert to be able to deploy and be successful with Stratus platforms. All of that can be remotely managed and monitored, and we provide extensive support for that, and we'll talk about that a little bit more. So again, the focus today, 5 edge opportunities to maximize revenue. And we want to start with what is edge computing. So edge computing is simply computing capability deployed at the edge of the corporate networks, outside of that DMZ, typically in the OT environment, close to critical processes and critical equipment. And that proximity is intended to address the bandwidth and latency concerns, the data volume that you have to deal with, and extract from the shop floor, deliver, in some cases over a WAN, to a control room, an operation center, and eventually to the cloud, so you can share that data across the enterprise for insight. Now, IPCs, computing powers, that existed for many, many years, but what's different, what's evolved in the past couple of years are the demands and the strains that are being put on that compute infrastructure. So what exists today is oftentimes not sufficient for where you want to go in the future. Software has become much more complex, and data has become the lifeblood of an organization, for that insight and for that decision making. So there's some unique requirements that have emerged where traditional IPCs have start to fall short pretty quickly, and clusters become too complex. So this gap that exists today creates a lot of opportunity for innovation and a lot of opportunity for SIs to do that work. Everybody on the line here with us today. So today our goal is twofold in this discussion. It's number one, provide a survey of where we see SIs having a lot of success with edge projects. And second, to provide ideas for your business. So there are 5 things that we're going to cover. And the first is around modernization. Projects. We see a tremendous value and a lot of business in that area, and a lot of opportunity to be successful here. So there are a number of things that we see driving those modernization projects. And within that, things like natural tech refresh cycles, that 3 to 4 year traditional cycle. We're going to talk about that a lot more, but that's a big driver. Troubleshooting around downtime, end users running into projects, operations being disrupted by downtime, data loss. So they're doing a lot of upgrade projects and modernization projects to address that. And sometimes as you know, the infrastructure has become impractical to manage. It's legacy systems, islands of automation, bespoke implementations, just hard to manage and maintain and to stay current. So another major driver there. We also see a modernization and infrastructure related to other projects like maybe there's a PLC upgrade that's going on that necessitates upgrading the compute infrastructure or outdated software. So all those things driving modernization, and that's really the bread and butter. There's great opportunities there and a lot of success. So what do we see people capitalizing on there? Number one, it's replacing that outdated IPC, let's say, with a more robust compute platform, higher performance, more memory, all the things that you get with a modern platform. They're also taking a page out of the IT playbook, and they're taking that platform with that built-in redundancy, and then they're adding a hypervisor on top of that so that they can get the most out of that platform, deploy layered software. And everybody's being tasked with doing more than less. Putting that current platform in place allows you to do that, run a hypervisor on that, and then stack on software to make that as robust as possible. And those are all parts of just upgrading the overall control architecture and the benefits that come there. So a lot of the benefits that you see that you hear from end users. Notably here, with a new platform in place, you now have that shared landing spot for both OT and IT. There's a lot more OT and IT convergence that everybody's seeing, and IT's has a equal seat at the table for these upgrade projects. Now, but when you step back, the modernization, is necessary. A lot of business here, but ultimately, the end user is not really doing anything new. They've just gotten current for the 30-year architecture they've had, and they've brought it forward, but nothing has changed. So one of the more important outcomes out of the modernization is really the ability to deploy a future-proof platform, create a future-proof infrastructure that then opens the aperture for additional services and lays that foundation for innovation that the end users are really turning to SIs for. They're looking for that innovation for that next project. These modernization projects get you there and then creates new opportunity. So I'll give you a couple of examples here. These are all things that if you check out our case studies on our website, just again, a survey of a couple types of examples here. So on the left side to start, we had an SI come in, and they worked with an oil and gas company and modernized their offshore platform. They did it in 45 days. They completely decentralized monitor control. They upgraded the communications infrastructure for their safety systems. And they were able to take 12 applications across 6 servers and consolidate that all onto a single fault-tolerant Stratus platform. So really simplified and modernized their operations. Similar with the chemicals manufacturer, they wanted to upgrade their DCS, but they didn't have the compute infrastructure because it was aging and it was old. So they were able to replace 9 physical servers with a single Stratus platform, completely consolidate those workloads onto one platform, get a lot more efficient, a lot easier to maintain, and they haven't had any downtime using that platform with built-in fault tolerance. And another example here, materials manufacturer, they were having a lot of downtime. They had disparate data across systems. They were able to, they took on a SCADA modernization project where, again, they consolidated different servers, including their recipe management, onto a single platform, single source of the truth. And they haven't experienced any downtime since 2016. So some great work here, great projects. But again, they've gotten current, but they now have that foundation. With that improved reliability and availability, they have that foundation to go now, move forward, and continue to improve operations. So that's where I'm going to hand it over to Rudy to talk a little bit more about those life cycles and the opportunity for everyone there.
Thank you, Doshik. Yeah, and as Doshik mentioned, right, it's modernization projects are a great opportunity in order for you to begin to shift the message from the cost of doing business, right, to how do we leverage a edge computing platform that enables you to do more. And really, I think what this point really hinges on is that you as system integrators provide great resources to your customers' organizations that really can identify projects and identify opportunities that actually deliver an ROI to your customers. So when we look at a traditional control system and control system platform built on a traditional IPC type model, we're looking at the life cycle of this deployment, and usually you have about a 3 to 4 year window. Maybe we're being a little generous with our 4 year here, right? But we have this typical process where we start on up-to-date hardware and software day one when we deploy it and we start up. And then as you move forward, that first or early part of the life cycle, you really can begin to do what we call the value add engineering processes, right? That value add engineering sweet spot where your engineers can really get in and to start understand the processes that your customers are dealing with, identify projects that have significant ROIs associated with them. That will then be built into the tech refresh planning cycle. And what happens there, if you'll click for me, Doshi, they'll identify these additional functionalities that provide a great ROI for end users, and they'll begin to integrate those into the tech refresh planning. That's usually being scheduled a year or two out during a shutdown or migration. And at that point is when they're going to actually begin to be able to deploy some of these digital solutions that we're looking at. And so really it's being able to capitalize during the modernization services on some of what the high value add engineering services are that your team can identify early on. Unfortunately, as we all know, during these migrations, it's a very stressful, scope-driven environments where many times what we're trying to do is we're so focused on that startup that you see there at the end that we may begin to remove some of those additional functionalities that we've identified that really provide an ROI to your project in order to help us meet budgets and deadlines that are required in order to start up on the date we said we're going to. So really you run risk that all you're really doing is keeping up with a modernization and obsolescence life cycle that is more associated with the cost of doing business and less associated with the value that your resources are delivering to your end users. And at Stratus, we've identified this as a significant challenge that our end users are dealing with. And one of the things that we've done, if you'll go to the next one, Doshik, is we've really focused on extending that life cycle of the supportability of the products. And what that allows you to do is you still have that year-long of planning that where you can plan your tech refresh, get through your shutdown and your startup towards the end of your life cycle, but we're stretching out that value-added engineering sweet spot that we talk about from when you deploy to when you actually need to start worrying about your modernization. And in stretching that out, that gives us a whole lot more time to really begin to identify some of these process improvements and software updates that are required in order to really begin to deliver what I would say are the higher value add services that your teams are very well trained to do and love to do. So the extension of the supportability of the products really is what enables that. But the other thing that we build into our platforms is virtualization. And what virtualization allows you to do is what you see here on the bottom, which is this closed loop innovation cycle of identifying additional functionality requirements with ROIs associated and being able to deploy them in real time into your existing system, test them out, see what works, see what doesn't work, deploy digital software-based solutions, integrate them into your operations, and if successful, scale them out across the entire organization without having to wait for a tech refresh cycle in order to do this. So not only do we extend the supportability of the systems, we're also making them much more reliable, right? So when you're looking at these 3 to 4 year life cycles, by year 3 and 4, you start to get a little bit iffy on what happens if this hardware breaks. With Stratus, what we do is we make sure that you've got the first-in-class reliability and availability of your control system, as well as this ability to add additional functionality and deploy digital solutions, integrate them into operations, and really capitalize on what your resources are highly trained to do, which is identifying opportunities for your end users to improve their processes. So once we do that and we have that shift, right? Again, this allows you to spend quite a bit more time in this sweet spot, and gives you a platform to start looking at some of the different software-based applications that are available in the market. And as we all know, the market is really the marketplace is really stepping up and providing us with a lot of software-based solutions that can be layered on into our OT/IT stacks. So what we're going to focus on here is what we're seeing as some of the emerging applications that you can begin to identify during these innovation cycles that are built into your product life cycle. And you know, one of the things to keep in mind is, you know, this platform, it may be there to host your DCS, or it may be there to host your SCADA system, but because it lends itself in order to also host some of the additional applications, you can begin to provide different services to your customers depending on what their needs are and what they're trying to achieve with their business. So some of the things that we commonly see, for example, are cybersecurity. You know, many system integrators are developing cybersecurity practices where they can identify different threats and weaknesses within an end user cybersecurity posture, and not only provide the services to test and identify where those weaknesses are, but also deploy solutions that are going to patch those potential vulnerabilities and you know, help extend their cybersecurity posture. Another area that we see the marketplace really step up is asset performance and reliability. You know, the infrastructure and the hardware that your end users are using in order to make their products, right? The actual machines themselves sometimes need to layer on software in order to predict failures, right? Predict the failures of your different assets, my motors, my pumps, my you know, my different equipment in the field. You can now begin to do asset performance and reliability utilizing software solutions that are out there. Again, leveraging your edge infrastructure. You could implement models in real time and monitor the health. Another area of service that you can look at are you know, orchestration and lifecycle support. And really that is around these software updates, right? What are the updates and the patches that your customers really need to deploy? When do they need to deploy them? Really, there are a lot of services that system integrators can come in and provide by identifying what those patches are and when they need to be deployed, as well as when they don't need to be, and being able to have a platform where they can do that efficiently. And then the final category I'll touch on is you know, it's all about data. And as we know, these assets are creating tremendous amounts of data, you know, and enabling IoT type solutions and data integration solutions into layers higher up in our customer stack. And we're seeing them actually virtualize quite a few of the network functions in order to relieve some of the stress on the existing network and bandwidth that the customer's applications may have. So we were able to relieve that by deploying some network functions, virtualizing them, processing that data at the edge, and really only sending what needs to be sent in a light framework versus a very heavy and costly data transfer method. So Really, I would say the opportunity for system integrators in this space is to create practices around some of these categories. So some of the practices that we're seeing system integrators take advantage of are performance management, right? How do I help this facility get more throughput out of it? How do I help make sure that that we're minimizing costs on our throughput, taking advantage of all the resources? Or maybe the customer is really focused on product quality, right? How do we make sure that that the manufacturer that we're supporting has the highest level of quality and at the lowest cost, right? They're eliminating waste, having fewer reruns, et cetera. You can begin to be a value-added partner who helps deliver on product quality or asset health, as we've mentioned before. Safety is also a very, very important category. Many times we see safety become important or more important and be highlighted after an incident, right? And so having these practices in place within your organization is only half of the story. You need to have the infrastructure in place as well to be able to deliver on what you identify as some of these projects. So as you know, when an incident happens or when any one of these categories becomes impactful to your end user's business, it's important for you to be able to identify, scope out a project, deploy and deploy a proof of concept and even a fully integrated project very quickly, while this is important and an important KPI that your customer's trying to address before that changes in the near future. So again, these applications as well as the platform really gives you as a system integrator an opportunity to build practices to support some of these demands from your end users. So a few examples that we'll share here with you, where a customer was able to leverage, or a system integrator was able to leverage an existing future-proof platform. The example on the left is an oil and gas company that actually took and integrated with information from their order management system in a terminal. They integrated that with their tank gauging system and their DCS in order to provide a digital twin that helped them come up with an optimized blending strategy and control platform that made sure that they were, one, not giving product away, but two, also making sure that they were delivering on spec, perfectly blended product in real time through their terminal to all of their customers. And as you know, in a refinery and in a terminal, the blending and the terminal really is your cash register where you can deploy some of this. They were able to shift from doing business as usual to finding a way to leverage both software and an edge compute platform to really optimize and start getting a very significant ROI from this solution. Another example that we'll share here on the right side is a major midstream oil and gas producer who actually had lots of different things at play here, right? They had requirements of upgrading their HMI and SCADA and control platform, and that was one team, right? And that one team is working with this scope in mind. And you had a cybersecurity team, maybe more of an IT team that was focused on what are the requirements for us to be able to make sure that we meet our TSA mandates for cybersecurity, right? They had to deploy firewalls, secure remote access, detection, password rotating, and you had that team working independently. And then you had a separate team that was working on trying to solve the bandwidth problem of how do we get high frequency and very valuable data without completely breaking their communications infrastructure and streaming everything back up to the cloud. And that solution needed to leverage edge computing. And then the last application that they were looking at, what was interesting is they had not really scoped this out yet, but really this was on vision systems and analytics. And they know that there are lots of use cases that they can address by putting smart vision systems out in their production environment. But they weren't exactly ready to scope out what that was yet. And what we were able to do is combine all of these into a single platform. Instead of having 4 different projects that each required its own communication, its own power, its own device, its own support and life cycle, we're able to combine all of that into a single reliable platform and deliver that in a combined package at a much lower cost than looking at each independently. And we're going to shift gears a little bit here into the project management piece. As system integrators, we all know that you can scope out and plan and estimate a project all you want, but really the profitability is going to be defined in the project management and handling all of the costs and the timelines and the risks associated with that. So I'm going to talk a little bit about how we believe edge computing can help you address that. And as Doshik mentioned, we really build some of these things when we're building our products. We have these things in mind of the features that we build in, as well as the go-to-markets and the partnerships we develop to make sure that we're addressing that. And we believe that edge computing can help you not only simplify your projects, but in the process of simplifying them, really de-risk your projects. And we all know that risk is one of the most costly things when it comes to a project. So de-risking is very, very important. So some of the things that we do is we focus in 3 major categories, which is the front end engineering and design, and maybe even pre-feed during the estimation process. We focus on your factory acceptance testing and how you can leverage edge computing in order to maximize your efficiency in your FAT. And then finally, we believe that a good edge computing system should really show its value when you're doing your cutover itself. So some of the things that we're doing is, for example, during your feed, we're focusing on making sure that you have very easy to scope and estimate your projects when you're leveraging our edge computing platforms. And what we mean by that is, being able to go from as little information as an IO count and being able to, with a high level of confidence, not only estimate what kind of compute you need from that IO count, but also the compute infrastructure that goes all the way around into a total installed cost, right? We'll share on the next slide how we do that. The other way that we believe our edge computing can be leveraged is the different redundancy requirements for applications. Some applications may have software availability built in, others may not. And so as you start looking at how available does each application need to be, what happens when one fails, your architecture can begin to get very complex. And so what we've done is we built in the availability into our platforms so that is taken off the table, and you don't have to define bespoke architectures depending on how available each application needs to be. We take that out of the question. And along with that, we're consolidating multiple workloads into a simple platform. We simplify the way you deploy that platform, which allows you then to make sure that you're de-risking and removing complexity from your electrical and network designs. Same with your FAT. Some of the things that we're focusing on is providing this characterized performance, right? That you can actually do in the actual compute environment that is going to be deployed in the field. So you don't have to worry that your revision during FAT may perform different than it's going to perform when it actually gets to the field and gets to a customer site. And then lastly, we believe that, probably the most important part as we try to get to that startup is the cutover. Right. So what we're doing by consolidating all of this is we're removing the physical hardware that you have to install, consolidating that all into a single platform, which makes it less hardware you need to install. You still have all the hardware you have to remove, less you have to install, right? And it's more simple to install it. And then probably the most important and overlooked factor when you're looking at de-risking a project is before startup. We know the very last part before you start back up is all of the testing and validating that everything works appropriately. So we get to the end of a shutdown. Everyone's tired from working multiple shifts, and the very last thing you have to do is go through every single failure scenario in order to make sure that your system is going to perform the way it needs to, in case of any scenario that you may have during operations. So this is a very stressful time, and we believe that this is something that edge computing and reliable edge computing can help you eliminate and de-risk by minimizing the amount of failover scenarios that you need to test right before a startup. Again, because we simplify it and we provide fault tolerance in our platform, you don't have to go through as many scenarios that you need to test, and we're eliminating the complexity that compute may add to your project. So some of the ways that we do, and this speaks really to the front end engineering and design and simplification. One of the ways that we're taking this a step further, because we are focused on industrial automation, is we're taking more than just our partners' recommendation for resources to software. And we're going a step further, and we're actually characterizing this with a lot of the major partners in the field. And we take on this extra step because we want to have empirical data that shows how does this actually perform when it's under stress and tested, so that when you come to us with an IO count, you can trust that that IO count is going to be enough information for you to be able to, with confidence, specify the server and the compute that you're going to need. And then furthermore, what we're doing is we're helping create reference designs for you in order to take the complexity out of the entire compute infrastructure that you need to deliver. And what we have found is that with something as simple as an IO count, you can get all the way to the right-hand side of this chart and have a complete turnkey compute scope that's deliverable to the field, that's going to be able to withstand power requirements that you may have, and power risk, environmental risk, and compute failure risk. And these engineered solutions, we put a lot of the engineering on the front end, and what we found is that they help you reduce your engineering time by 40% and help you deliver projects about 20% faster. So here, what we have is a few examples where some of our customers have been able to leverage some of this and really reduce the total installed cost of their projects and deployments, as well as de-risk them. I'm not going to go through all of these examples, but as you can see, when you start looking at this, the main points that we're hitting here is we're providing a highly reliable, highly simplified infrastructure that is easier to deploy, de-risks your project, and then allows you to focus on some of the riskier parts of your project, dedicate resources, and hopefully not cut from scope the really value-adding portions of your project that justify the project in the first place. So allows you to remove the complexity from compute and deliver the portions of the project that really hold the ROI. So with that, I'm going to hand it back over to Doshik to walk us through the last key point that we have here, which is how you support these systems.
Thank you, Rudy. So yeah, that's exactly right. One of the big questions that we hear from end users, how are you going to support this project? At one point, sustained value was a real focus. You're certainly getting those questions from an IT department who, particularly if they're less familiar with Stratus. The good news is we have robust support, and that creates another opportunity for you as an SI to maintain that engagement with end users. So one of the hallmarks of Stratus platforms is that they're uniquely engineered for serviceability and proactive health monitoring. So on that latter point around health monitoring, what does that mean? We monitor, for example, in F2 Server, more than 500 potential points of health in that platform, and we have automated alerting set up that either goes through our dedicated network or can go through an end user's existing communication network using the protocol of their choice. So it's pluggable into your existing infrastructure. So oftentimes Stratus gets alerts about system health before an end user even is aware that there's a potential issue. So some of the key points here, we offer a one-stop shop for all platform and OS support. So whereas with other solutions, you might have to make a couple of different calls to the hardware provider, to the hypervisor provider, to another software vendor related to the host OS. There's one call with Stratus. We find that more than 99% of potential issues are resolved remotely, so we don't need on-site support. And we have that 24/7 monitoring by the Stratus teams. And as Rudy talked about, that life cycle, the serviceable life of our platforms, that's usually about twice the industry standard. So in more in that 7 to 10 year range, which again extends that innovation window for SIs to really focus on the value add work with end users. Some of the specifics around our platforms, the hardware platform is designed to be serviceable by OT or IT. You can hot swap modules, what we call CRUs, customer replaceable units, so that you've got that built-in redundancy. If one module goes down, the system keeps running without downtime, without data loss, and you can hot swap that component, that module, without any specialized IT knowledge or any tools. Talked about the software monitoring, the proactive health monitoring that we have, for that that complete solution of hardware, reliability, performance, serviceability, and manageability. That creates the opportunity for SIs to offer that support, that long-term support that's provided by Stratus. You have the opportunity to resell that to end users, to answer those questions around how you're going to support the platform moving forward. One of the things that the customers have asked about at various points is, do they pursue this, that power by the hour type of offering where it's based on outcomes, rather than the individual components in the install. But those are all things that are available with our platforms, again, because they're uniquely engineered to be serviced and monitored. And we deliver that 24/7 with our experts. So that, again, takes the heavy lift off of an internal IT team. Even as a SI, if you want to provide support, that takes some of the heavy lifting off of you so that you can, again, focus. You don't have to worry about the compute infrastructure running. We worry about that. That's oftentimes, helps it become transparent to the end user so you can focus on that innovation cycle. And just to close here, some of our platforms specifically, these are our three main platforms that we offer. The ZTC Edge is that, Xbox size, hardened, protected. It's in an IP40 Class 1 Div 2 certified enclosure. Paired together, those two units provide high availability or fault tolerance. They have built-in virtualization, built-in redundancy. So you don't have, when they're paired together with those the blue and yellow connections, you don't have any downtime or data loss. Run up to 4 VMs on it. FT server, it's our workhorse, traditional rack mount server, 20 to 30 VMs, up to 50,000 IO, and it delivers that 6+9 availability, so you don't have any downtime or data loss. Underneath that bezel, you have 2 hot swappable customer replaceable units. So if there's an unrecoverable error that occurs, again, you don't have any downtime or data loss, but you just swap out that CRU and the system keeps on running. And our most recent offering, ZTC Endurance, intelligent predictive fault tolerance. Based on that 100 million hours of runtime analysis, we know what's going to fail. We can predict what's going to fail before it even happens. More modular. So rather than 2 customer replaceable units, you have 4 pairs of customer replaceable units for the individual IO, storage, CPU, those modules there. And it's got 7.9 availability. So, it's on 4th generation Intel processors, blazing fast. That is really the foundation for future operations. Just to look at our platforms here. Now, what do we do to make SIs successful? Well, we launched a couple of years back, we launched a specific system integrator program for accreditation and to help SIs become proficient and successful at the edge. So there are a number of training courses, badging system. What we hear from end users is that they appreciate the badging and the certification, so that they know that somebody's coming on site. They're certified, a certified Stratus system integrator. Again, de-risking the project, making it as predictable as possible. And on the left-hand side, just some of the benefits that we offer through the program. The accreditation and the badging, e-learning tools to become proficient with our platforms, access to discounted demo systems, and inclusion on our partner locator. So on our website, if somebody is looking for a certified SI, a Stratus implementer, you're going to be in the partner locator. But I encourage everyone to take a look at this program. A lot of benefits, and it's all aimed at helping our SIs be as successful as possible at the edge, and to capitalize on those emerging opportunities that we've talked about here. So lastly, thank you for the time this morning. Again, the goal was to give you an idea of what some of your peers are doing, and to talk about the opportunities that are emerging at the edge to help solve some really complex but exciting things for end users. On the right-hand side, we have on our website, we have a SI compendium. It's a compendium of a survey of successes, different examples, some of which we talked about on the call today. Encourage you to take a look at that. If there are examples of things that you're doing, we're definitely interested in learning more. At this time, we'll kind of open it up for questions, but we'll leave you, with this final thought on screen about the value that we deliver, and what we're trying to accomplish with all of you. But again, open for any questions that people have at this point. Now I'll turn it over to Lisa. I think you're gonna kind of moderate that.
Yeah, I am. So before I get started on that, though, why don't you go ahead and copy and paste the links that would be helpful to people in the chat. I think you had a link to the SI program landing page, and maybe there's some contact information you want to pop into the chat, or maybe one of the other team can do it because you don't have it handy, but might be helpful for the peoples. Okay, so one of these questions here is, can a system integrator receive notifications for service instead of the customer?
Yeah, I'll take that. So the short answer to that is yes. Really, the way we've designed the Stratus services is to be integrated into whatever the support model is of the entire solution. We know that many times, even if the compute system fails, we may not know if it's a problem with the software, if it's a problem with the configuration, if it's a problem with the actual compute infrastructure itself. So what we do is, when our systems phone home, when they're configured, we actually we'll diagnose and we'll route that information through whatever the appropriate channel is. And if you're the system integrator on record that has the support agreement with the end user, then that information will go directly to you, as well as with detailed information as to what the corrective action is that needs to be taken.
So I know you touched a little bit on this, but can you tell me a little bit more about the training and certification programs available for the Stratus platforms?
Doshi, you want to take that, or?
Sure. Yeah, I'm not sure what specifically to cover there, but the best thing to do for the details is to go to the website on the link to learn about the specific requirements and the specific benefits. So in terms of moving up through the tiers, there are a couple of different programs there for depending on your role within your organization. Different levels of technical training, whether it's just the general ability to deliver some of the Stratus basic information versus some of the technical install information. One of the things that we, as part of the proficiency, is we want to work with you to make sure that you've documented some specific examples or specific installs that you have that demonstrate that proficiency. But the details of moving up through those different tiers, that's all in the program brochure.
Okay. Does Stratus offer edge computing as a subscription model?
No, that's not something that we currently offer. Now, many times what we're seeing is system integrators may leverage edge computing and a Stratus offer as part of what a subscription that they may deliver, right? So, hey, we're delivering reliability as a service. Edge computing may be a component of that. However, we're letting our system integrators and our market provide that to our customers.
All right, so final question before my colleague Karina puts up my slides, which is my hint to her to get it ready. How does a Stratus platform compare in cost to a traditional cluster?
That's I think that's a great question, and if you really want to dive into detail, we do have some total installed cost and information on our website. But really, it comes down to how you compare it to whether you're comparing to a simplex environment or to a highly available cluster. And when you start looking at both the total installed cost of all the hardware and software that you need to put together in order to create an HA system, what you'll find many times is that a Stratus system is going to be lower cost because it's built for purpose to provide that high level of availability or even fault tolerance when compared to a high availability cluster. There are going to be several factors in it, including what we discussed today, which is how long is this solution going to last? How long is it going to be supported? And what level of availability do you need? But I would say that most of the time, as long as we're comparing apples to apples, it's going to be significantly lower cost than a traditional cluster.
Thank you.
Yeah, just to pick up on that from Rudy, that's a common question, a common consideration that comes up with SIs, and there's the two other dimensions of that. Is it the right approach, the right system for the need? And then what's gonna be the impact to the organization, if it goes down, and how do you recover from that? So that sometimes goes beyond the actual cost. It's the impact to the organization, that recovery time. Do I have IT resources on site who can get me back up? And back to the simple, protected, autonomous, is that something that you need in your environment? Or do you need something or is it practical to use something more complex like a cluster?
Great, thank you. So we just have a couple more slides as we close it out, and my colleague Karina is going to do that for me. On behalf of CSIA, I would like to thank our speakers for this informative discussion, and I would also like to thank Stratus for sponsoring this event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thanks for joining us and have a great day.